Our project topic is Advanced Market Segmentation using Deep Clustering, targeting customers using deep learning. This code performs customer segmentation using a combination of a variational autoencoder and deep embedded clustering. It aims to group similar customers together based on their characteristics. So, firstly, we are importing libraries. This section imports necessary libraries for data manipulation, visualization, pre-processing, clustering, and building neural networks. Pandas is used for data handling, NumPy is used for numerical operations, matplotlib.pyplot and seaborn are for creating visualizations. sklearn provides tools for pre-processing, dimensionality, reduction, and clustering. TensorFlow and Keras are used for building and training neural networks. So the next is we are loading the data set and pre-processing it. The code loads a dataset from a CSV file named unsupervised customer data.csv into a pandas data frame called df. It then prints the first few rows of the data using df.head pre-processing. It removes the customer ID column if it exists. It converts any categorical features into numerical representations using label encoder. This is important because many machine learning algorithms work best with numerical data. It applies feature scaling using standard scaler to standardize the data. This ensures that all features have a similar range of values, which can improve the performance of the clustering algorithms. Next is building and training the VAE, variation autoencoder. This function defines the architecture of the VAE, which consists of an encoder and a decoder. The encoder compresses the input data into a lower dimensional representation, and the decoder tries to reconstruct the original data from this representation. The training involves the VAE is trained using the scaled data for 50 epochs with a batch size of 16. In encoding, after training, the encoder part of the VAE is used to obtain a lower dimensional representation of the customer data. So next we are implementing deep embedded clustering, DEC. This function calculates the target distribution for the clustering process, build DEC function. This function defines the DEC model, which is built on top of the encoder from the VAE. It adds a clustering layer to the encoder to assign cluster labels to the data points. The training involves the DEC model is trained iteratively to refine the cluster assignments. The for loop runs for 10 epochs, updating the cluster assignments in each iteration. Cluster labels. The final cluster assignments are stored in DEC labels. Next, we are doing k-means clustering. In this part of the code performs k-means clustering on the encoded data obtained from the VAE. This is done for comparison with the DEC results. It uses 4 clusters and sets a random state for reproducibility. Next is visualization and evaluation. It uses TSNE to reduce the dimensionality of the encoded data to 2 dimensions for visualization. It then creates a scatter plot showing the clusters obtained by DEC using different colors for each cluster. Silhouette score. It calculates the silhouette score to evaluate the quality of the clustering. The silhouette scores measures how similar a data point is to its own cluster compared to other clusters. Results table. It creates a table showing the original data along with the cluster assignments from both DEC and k-means. This allows for comparison of the 2 clustering methods. This code uses a combination of VAE and DEC to perform customer segmentation. It pre-processes the data, trains a VAE to learn a lower dimensional representation, and then uses DEC to cluster the data in this lower dimensional space. It also compares the results with k-means clustering and visualizes the clusters. The silhouette scores is used to evaluate the quality of the clustering. In summary, The dataset presents customer segmentation results using deep embedded clustering and K-means. The scatter plot visually represents DEC clusters in reduced dimensions, showing four distinct customer groups. The table includes key customer attributes such as age, income, spending score, online visits, purchase frequency, loyalty, and product preferences. Each customer is assigned a DEC cluster and a K-means cluster, allowing a comparison of the two methods. DEC, a deep learning based approach, can uncover more complex patterns, while K-means relies on distance based clustering. This segmentation helps businesses identify customer behaviors, optimize marketing strategies, and enhance customer targeting. Thank you.